If you've spent any amount of time in IT security, you know there are many different security risks that you need to prepare for. The attackers are looking for different ways to gain access to our systems, and we need to find different ways to prevent them from getting that access. But of course, we're not just protecting data, we're also protecting physical systems, buildings, people, and everything in our organization. In this video, we'll look at different security controls and how they can be used to prevent events from occurring in the first place. We can minimize the impact of events that ultimately do occur, and in many cases, we can limit the damage if someone does find a way into our computing environment. Let's look at some very broad categories of security controls. The first category we'll look at are technical controls. These are controls that we implement using some type of technical system. So if you're someone who is managing an operating system, you might set up policies and procedures within the operating system that would allow or disallow different functions from occurring. We can also put firewalls, antivirus, and other types of software into this category of technical controls. As a security administrator, you'll also want to create a series of policies that explain to people the best way to manage their computers, their data, or their other systems. We refer to these as managerial controls. So if you are creating a series of policies and procedures, or you're creating an official security policy documentation, you'll often put these managerial controls inside of your security policies. You might also see these managerial controls implemented into day-to-day processes as part of your standard operating procedures. Another important control category are the operational controls. Unlike using technology to manage these controls, operational controls are using people to be able to set these controls. So if you have security guards at your place of work, you're doing monthly lunch and learns, or you have some type of posters or awareness program at work to help explain the best practices for IT security, then you can put these into the category of operational controls. And the last category that we have are physical controls. As the name implies, these are controls that would limit someone's physical access to a building, a room, or a device. This might be something like a guard shack, so they can check everyone coming into a particular area. Maybe there are fences and locks to keep people out, or maybe you use badge readers to limit the access into certain areas within your building. So in this video, we'll focus on these four categories of controls: the technical, managerial, operational, and physical. And in this video, we'll look at a number of different control types and determine where we would fit certain control types into certain categories. The first control type we'll look at is a preventive control type. This is a control type that limits someone access to a particular resource. You can think of this as something like a firewall rule, which would prevent somebody from gaining access to a particular area of your network, or it may be something that's more tangible, such as a guard shack checking everyone's identification as they come into your facility. A good way to test yourself with these different control types is to determine what category will a certain type fit into. So when we deal with preventive control types, we can look at firewall rules, and since those are handled at a technical level, then those would fit into the technical category. As we hire people, we may want to set a certain type of policy for onboarding, and those would be policies set as part of a managerial category. We've already mentioned a guard shack checking everyone's identification, and since that's done by a person, we can fit that into an operational category. And lastly, we have door locks, which are physical devices preventing access to a room, so that would fit into the physical category. Another important control type is a deterrent. And although a deterrent may not prevent someone from accessing a resource, it may give them a discouragement or have them think twice about the attack that they're planning. For example, when you start an application, there may be a splash screen that provides security information and restricts people who are not authorized from gaining access to that system. Or there might be the threat of a demotion or a dismissal if somebody gains access to data that they should not be accessing. There might also be a front reception desk greeting everyone who walks in, or warning signs telling people that if they gain access to this facility, that there would be consequences. These fit perfectly into our four categories. A splash screen is a deterrent that fits into the technical category. A demotion is a managerial category. The reception desk fits into the operational category, and the warning signs are a physical deterrent. A detective control type can identify and in some cases warn us when a particular breach has occurred. This may not prevent access, but it would give us a warning and log information about that particular attack. An example of a detective control type may be a process of collecting, reviewing, and going through system logs, or you may be reviewing login reports about who's gained access to your systems. There might be someone patrolling the property looking for cases where someone might have broken into your facility, and you might have motion detectors so that you're automatically notified if something is moving in an area where normally there should be no motion. The system logs that are detailing everything that's going on in your systems fit into the technical category. Someone reviewing login reports every day or every week would fit into the managerial category. Someone patrolling the property would be an operational category, and then the motion detectors provide us with a physical category. If there is a notification that someone has breached a system or gained access into a certain area of your business, then you want to apply a corrective security control. A corrective security control is something that occurs after the event has been detected. This is sometimes able to reverse the impact of that particular event, or you may be able to continue operating with your business with minimal downtime thanks to these corrective controls. For example, if a computer has been infected with ransomware and it has encrypted everything on that system and made all of the data inaccessible, you can simply erase everything on that computer and restore it back to a known good system using your backups. You might also want to create policies so that if there are security issues or something unusual that you see happen, that those would be rolled up into an alert or some type of notification. And if you find that someone has jumped your fence or they've tried to get in through a door in your building, you may need to contact law enforcement to be able to correct that particular incident. And if something is caught on fire, you can grab a fire extinguisher and make sure that that fire doesn't spread any further, thereby correcting that particular event. And as you might expect, those are 4 events that certainly fits into the 4 categories that we have. For example, recovering from a backup would be a technical category. Being able to have policies for reporting issues when they occur would be in the managerial category. Contacting authorities for some type of legal issue would be an operational category, and your fire extinguisher is a physical category. You might also find yourself in a situation where a security event has occurred, but you don't have the resources or means to be able to reverse what that particular event has caused. In those cases, you may want to use a compensating control type, which provides you with using other means in a way to control that particular security event. This may be something you use on a temporary basis until you're able to put together a plan to resolve the overall security incident. For example, you might have an application that is important for your organization, but the application developer has told you that they've identified a significant security vulnerability in that software. Since the application developer is going to provide you with a patch sometime in the future, you may want to set some type of firewall rule today that will prevent somebody from exploiting that particular vulnerability. Or this might be a case where you can separate different duties between different individuals and limit the scope of any type of security concern. Or you might have multiple security guards all working at the same time to make sure that no single security guard has complete access to everything in your environment. And if you lose power in your building, you might want to have a generator so that while you're waiting for main power to be restored, you can compensate by turning on your generator. Those are our 4 different categories of a compensating control. We have a technical category of blocking that traffic instead of patching the application. There may be a separation of duties for the people that work in your organization, and that fits into the managerial category. You might require multiple security staff working simultaneously, and that would be the operational category. And lastly, having a power generator to compensate for a power outage fits into the physical category. The last control type we'll look at is a directive control type. This is a relatively weak security control because it is one where you are directing someone to do something more secure rather than less secure. For example, you may require everyone to store sensitive information into a protected and encrypted folder on their system. This requires the user to make a decision about what data may be sensitive and what data may be non-sensitive, and that they are directed to store the sensitive information in the protected folder. As part of our security policies, we may want to add compliance policies and procedures so that everyone understands the proper processes to use for security in your environment. You might also train users on what the proper security policies might be. And another example of a directive control may be a sign that you put on a door that says authorized personnel only. There might not be a lock on the door, but the sign saying authorized personnel only directs people to either enter or not enter that particular door. So to summarize these, our file storage policies will direct people to this technical category. A compliance policy fits into a managerial category. Someone performing a security policy training course would be a directive control type fitting into the operational category. And a sign on a door that says authorized personnel only fits into the physical category. The examples I provided for the different security controls and the categories where they fit were simply one single example. You can probably think of a number of different examples that you can fit into any of those squares in our matrix. You could probably also think of different security controls that might fit into a different category of control or a different type of control. You might also find as our technology changes and our security processes evolve that there might be new control types that we could fit into our chart. And of course, not everybody uses the same security controls, so the ones that you use in your organization may be very different than someone else's organization. The CIA triad is an easy way to remember the fundamentals of IT security. Sometimes you'll see this referred to as the AIC triad to differentiate it from the federal organization in the U.S. called the Central Intelligence Agency. But since it's so easy to remember CIA, we often refer to the CIA triad instead of the AIC triad. But keep in mind that the CIA triad has nothing to do with the CIA being the Central Intelligence Agency. The C in the CIA triad is confidentiality. We want to prevent someone from gaining access to private information. We need to provide that information in a confidential way. The I in CIA is the integrity, where if we're sending information from one person to another, we want to be sure that the recipient really is receiving exactly what was sent from the origination. And lastly, the A in the CIA triad refers to availability. Obviously, we want to be sure that all of our systems remain up and running at all times, even if we're implementing some type of IT security. You'll often see the triad written as a triangle, and each leg of the triangle has the confidentiality, the availability, and the integrity listed as the security objectives associated with the triad. One of the biggest challenges we have in IT security is making data available to others, but making sure that availability is only to the right people. We refer to this as confidentiality. One way that we provide this confidentiality is through encryption. We can have one person encrypt data, send it to someone else, and that other person can then decrypt that data to be able to see the original plain text. Obviously, anyone in the middle who happens to get access to that encrypted data has no idea what's on the inside, and if they were to look at that data, they would not be able to discern anything important from that information. Another common way to provide confidentiality is to set limits on what someone may have access to. We commonly do this with access controls. We can limit who might have access to certain types of information. For example, this might allow someone in the marketing department to be able to see all of the marketing presentations and be able to make changes to those, but it will prevent all access to any of the accounting information of the organization. And if you've ever had to provide additional authentication factors when logging into a system, that's another type of confidentiality. Someone would not be able to access an account unless they have the proper authentication credentials, and adding those additional factors provides more confidentiality. When we're receiving data from a third party, we'd like to be able to verify that the data that we have received is exactly the same data that was sent, and that nobody has made changes to that data while it was traversing the network. We're able to do that by using methods of integrity. One way to provide integrity is by hashing. The person sending the data will create a hash of the data, sends you both the data and the hash at the same time. When you receive the data, you'll perform the same hashing function, and if your hash matches the sender's hash, then you know the data that you've received is exactly the same as the data that was sent. We can enhance this integrity by including a digital signature when we're sending data, which takes a hash and encrypts it with an asymmetric encryption algorithm. This means that we can check to make sure that none of the data has changed, and we can confirm the person who sent the data. That provides an additional level of integrity that could be important if you're sending very sensitive data. It's also common to use certificates to be able to identify devices or people and provide additional factors of integrity, especially when you're transferring data from one device to another. And lastly, we have the concept of non-repudiation. This means that we have proof of integrity, and we can confirm without a doubt that the information that we've received really did come from the originating party. If you've done any work in information technology, you know how important it is for your systems to be available. Availability is that leg of the CIA triad that ensures that people have access to the data that they'd like to view. One way to provide this availability is to have systems that are designed to always be up and running. We might combine this with a system that has fault tolerance, where we have multiple components, and if one of those components fails, the other component can pick up and continue to operate normally. And of course, if you're concerned about systems being available, you'll constantly need to make sure that they are managed and updated by patching those systems. This ensures that the systems are always as stable as possible and that we can close any existing security holes, preventing someone from gaining access through some type of exploit. One of the important foundations of cryptography is ensuring that when someone sends data to a third party, that third party is able to verify that information really came from the sender. This is something that we think of all the time as part of a contract. We sign a contract at the bottom, it's our name, it's our signature, and if somebody was to look at this contract later, they can see our signature and could reasonably say that the contract was signed by us. Just like our signed contract, we have a similar set of features in cryptography. And today we'll look at how this non-repudiation works using proof of integrity and using proof of origin with high assurance of authenticity. Proof of integrity means that any data that we've received, we can verify that it's exactly the same data that was originally sent. This means that our data is accurate, consistent, and we know that nothing inside of the data we've received has been changed. In cryptography, we can accomplish this by using a hash. A hash is a short string of text that we can create based on data that is contained within
Drop the link about SANS Institute in the chat.
This means that
we'll get to that.
Changes with
but
that data,
bookmark that page. SANS stands for System Admin Audit Network and Security Institute. So they help give baselines, right, for networks, best practices. All right. Might be an organization you like. So bookmark that and keep it in your Rolodex.
The data that we've received is exactly the same as the data that was sent, but we can't verify who sent the data. However, there are ways to provide that additional integrity. We'll talk about those in just a moment. Let's see how this hashing works by using a practical example. There is an organization called Project Gutenberg on the internet, and they have published the Gutenberg Encyclopedia. I downloaded volume 1 of that encyclopedia, and it's 8.1 megabytes of data. And then I ran an application that took all of that data and created a hash or a fingerprint of that particular encyclopedia volume 1. And here is the exact hash that I've created from that volume. Now, if I was to change one character inside of that file, anywhere, although the size of the file is exactly the same after making the change, somewhere in that haystack of data, there is some type of difference. But it'd be very difficult for a human to read through all of that data, 8.1 megabytes of text, and somehow determine where that individual change might be. But if you perform a hash of the changed data, you'll see that the hash value that I create is very different than the hash value that was original. So if I have downloaded this file, perform my own hash, and compare it to the original, I can see that something has indeed changed with this particular volume 1 of the Gutenberg Encyclopedia. At this point, we might want to download again to see if we happen to get a corrupted or modified version, or perhaps we perform a diff or a comparison between those two files to see exactly where the change might be between the original version of the volume 1 and the version that we received. By using these hashes, we're able to provide proof of integrity. We know if anything was changed when the information was sent from the original sender. But we can also add to this an additional level of integrity called proof of origin, where we can verify the person that sent the data to us. Sometimes you'll see this referred to as an authentication when we are looking at the source of the message. By using a digital signature, we provide non-repudiation. So not only do we know the person that has sent that data to us, but anyone else could examine this transaction and verify that the information we received really did come from the sending party. Just as someone can use a pen and paper to sign a contract and send it to you, in cryptography we use a digital signature. This digital signature uses a private key that is only known to the person who's sending the data. No one else has a copy of this private key. To verify that private key was used, we use the public key associated with that private key, and that way we can assure that the information we received is not only the same as what was sent, but we know that it had to be sent by the person who provided the digital signature. In practical terms, adding a digital signature to a document is usually created by clicking a box that says add a digital signature, and a lot of cryptography happens behind the scenes. Let's lift the hood a little bit and see what that process might be that's taking place when you check that box to add a digital signature. We'll start with a conversation that's occurring between Alice and Bob. Alice is sending a message to Bob that says, "You're hired, Bob." And the first thing that Alice will do is provide a digital signature before she sends it. The first thing that happens when she clicks that checkbox for the digital signature is that a hashing algorithm creates a hash of that plain text. In this case, the plain text is, "You're hired, Bob." Once that hash is created, we now need to have some way to verify that it really came from Alice. And since Alice is the only one with her private key, we're going to encrypt that hash with Alice's private key, take that encrypted hash, send it along with the plain text so that Bob is going to receive a message that says, "You're hired, Bob," and then attached to that message is a digital signature. In most cases, Alice is going to send that message over to Bob using email or some other type of electronic delivery. Bob is going to receive exactly that message that was sent. It says, "You're hired, Bob," with the digital signature included with it. Bob is going to use Alice's public key, which is a key available to anybody, and he's going to examine the digital signature and decrypt it using that public key. Once that decryption takes place, we have the original hash that was created of that plain text message. And at this point, Bob wants to see if the hash that was in that digital signature matches the hash of what he received. So he's going to perform the same hashing function that Alice originally performed. Bob is going to take the original plain text, run it through the same hashing algorithm to come up with a hash of what he received. Bob can now do a comparison to see if the hash that was included with the digital signature is the same as the hash that he manually created from the plain text. And if that matches, we not only know that the information we received is exactly the same as the information that was sent, but we know that it had to be sent from Alice. As I mentioned earlier, this entire process of creating a digital signature and verifying the digital signature is something that's usually created through clicking a button on your screen, or it's something that happens automatically. You normally never see this process occur, but having an understanding of the digital signature process and the verification of the digital signature process can help you better understand the integrity that we're looking for and the proof of origin that's so important when working with transactions like this. all very familiar with the login process. You put in your username, your password, there might be some additional authentication factors, and if all of those are correct, you gain access to resources on that system. This process begins with identification, where you claim to be a particular user on that system. The check between your username, your password, and the other authentication factors is referred to as authentication. This proves that we really are who we say we are because we knew the secret password or we had some additional authentication factors that we could use to help prove that we are that person. Now that we've identified who we are, we now need to determine what type of access we have, and that's done through authorization. If we're part of the shipping and receiving department, then we should have access to systems that should only be available to shipping and receiving, and we should not have access to information that might be in the finance department. And of course, all security systems need to have a log of exactly what happened. So we need to know what time someone logged in, how much data may have been sent or received, and what time this person logged out. We refer to this entire system as the AAA framework, and this refers to authentication, authorization, and accounting. Let's have a look at a practical example of using AAA. We're going to use the example of logging into a VPN server. In this case, it would be a firewall or VPN concentrator in the middle. You're on one side of that concentrator, and you need to use AAA to gain access to an internal file server. So we'll start with our client on the internet, and we'll access the VPN concentrator, which prompts us for a login. So we're going to provide a username and password and send that information over to the VPN concentrator. The concentrator itself doesn't have any information about usernames, passwords, authentication factors, or anything else. And in most organizations, all of that information is stored on a central server, and we refer to that as a AAA server. This AAA server is going to receive the request from the VPN concentrator asking if the username, password, and other information that was provided matches some type of user in the database. And if the match is true, it sends back information to the concentrator and says those credentials are approved. At that point, the concentrator knows that we really are the person we claim to be, and it allows us access into the internal file server. As a security professional, you'll be responsible for managing the security on hundreds or perhaps even thousands of separate systems. And in many cases, you'll never have physical access or even be able to see where those systems might be because they may be located anywhere in the world. So the question now becomes, how can we verify that a computer trying to connect to our network is a computer that's authorized to be on our network? This computer by itself obviously can't type a password to prove who it might be, and in most cases, you probably wouldn't want to store a password on one of your systems out in the field anyway. So how can you really confirm that system is allowed to be on our internal network? How do we provide that additional authentication? In many cases, we use a certificate that we put onto this device that is digitally signed, and we check that authentication during the login process. This allows anyone needing to provide that verification with a way to confirm that that really is a company-owned laptop. This could be on a VPN concentrator so that it can verify that the devices coming into the network really are company devices, or perhaps it's management software that can validate that end device that may be either on our local network or anywhere in the world. The process for creating this certificate is relatively straightforward, but the one thing that you must have in your environment is something called a certificate authority, or a CA. This is a device or software that is responsible for managing all of the certificates in our environment. On the CA itself, you would create a certificate just for that laptop. That certificate is now digitally signed by the certificate authority so that later on we can verify that it really is an original certificate from our certificate authority. Now we put that certificate on the laptop, and anytime we want to perform an authentication, we can use that certificate as an authentication factor and verify that it really was digitally signed by the certificate authority. So as part of your security infrastructure, you would have a certificate authority. That certificate authority itself has its own certificate that was signed by a root CA. We also also have our laptop in the field, and we have previously created a device certificate just for this machine, and it has been signed by the CA. Once we know the CA certificate and we know the device certificate, we can then compare these two certificates, and we can see that our device certificate was signed by the certificate authority that we trust in our security infrastructure. Now that we've gone through the authentication process, how do we authorize that device to have access to resources within our network? We would do that by using an authorization model. And there are many different authorization models to choose from. We have a big list of these later on in the video series in section 4.6. We would commonly authorize users and services to have access to certain types of data and applications. The challenge here is, how do you create this relationship in a form that's able to easily scale for tens, hundreds, or even thousands of users? In many environments, we accomplish this by taking the users and services and putting an authorization model right in the middle before you access the data and the applications. These are commonly defined by roles, organizations, attributes, and many other types of characteristics. Let's say that you had no authorization model at all. We would create a series of rights and permissions where the user has rights to access the resource. The problem is that this doesn't scale very well. Let's take an example of somebody in the shipping and receiving department. This is someone who needs access to a large number of systems, a lot of data. Maybe there's tracking information, shipping labels, databases of customers, and we would create separate rights and permissions so that anytime this person logged in, we would need to give them rights to create a shipping label, track a shipment, view monthly shipment reports, access customer data, and perhaps anything else they need for their day-to-day operations. Now, if this is the only person in shipping and receiving, this is a relatively easy process. But what if you're part of a larger organization that has tens or hundreds of people in shipping and receiving? You can see it would be difficult to take.
All right, everybody, looks like it's almost 5. Let's go ahead and take 10. When we get back, prepared statement is code trying to understand SQL injections and how SAST prevents it.
You would need to set those up for the tens or hundreds.
Prepared statement
you can see now why
is
this
in
very
code.
Difficult to scale.
Yes, I will break that down for you when we get back. The best I can. Now, full transparency, I'm not a coder. But we can dig into it. That'll bring out some basic things for you.
This
But yeah,
greatly
help you understand.
streamlines the process of administering these large number of users or large number of resources, and we can support a very, very large infrastructure just with a very simple set of abstractions. Here's how this would work. We'd have the same user, shipping and receiving, and we will add them to a group called shipping and receiving. We set this group up originally so that anybody added to the shipping and receiving group would have access to create a shipping label, track a shipment, view monthly shipment reports, have access to customer contact information, and anything else you would need in shipping and receiving. Now let's add in our tens or hundreds of users. Instead of manually mapping every single user to the individual authorizations they need, we just simply add all of the users to the shipping and receiving group. With this one single addition, we can give tens or hundreds or thousands of users access to the resources they might need, regardless of how many users there are and regardless of how many resources they need to access. As the name implies, a gap analysis is a study of where we are versus where we would like to be. And in the world of IT security, we are constantly performing gap analyses to be able to understand exactly what security is going to be needed in the future. Although this is very simple to explain, it's a relatively complex process to perform the analysis of what's actually going on in your environment and putting together a plan of how to get from where you are to where you're going. As you might imagine, trying to understand every aspect of IT security and how it applies to your organization can be a very involved process, and this is something that commonly takes a number of weeks, months, or even years to compile. As you can imagine, this might involve a number of different people in your organization, and there is an extensive project project plan with emails and data gathering and anything else that's needed to compile the information about what's happening with security in your environment. Before starting the gap analysis, it's useful to have a baseline. This gives you something to work towards and an idea of where the goals should be for your organization. There are a number of different baselines to choose from, and some of these baselines have been specifically created for certain organizations. For example, your organization may be following a set of baselines from the National Institute of Standards and Technologies. They publish a document called the Special Publication 800-171 Revision 2, and the title of that document is Protecting Controlled Unclassified Information in Non-Federal Systems and Organizations. You might also use a baseline that was created by the International Organization for Standardization and the International Electrotechnical Commission. This is the ISO IEC 27001, or the Information Security Management Systems. And of course, you could create your own baselines based on your specific needs as an organization. These baselines will commonly involve an analysis of the people in your organization and the processes you use for security. When evaluating people, you might want to get a better understanding of their formal experience in information technology security. You might want to understand what kind of training they've received, and you might want to see if they have a knowledge of specific security policies and procedures that you can use in your organization. Even with the right people in place, you'll still want to be sure that you're following the correct policies for IT security. This might start with an evaluation of the existing IT systems and how they relate to your formal policies that have been created in your central security policy documentation. The analysis portion of the gap analysis will begin with a comparison of the existing systems that you have running in your environment and to identify any weaknesses that those systems might have. You can also compare these weaknesses with the most effective processes for understanding how to compensate for those weaknesses. Ultimately, you'll create a detailed analysis where you'll look at very broad categories of security and then break down those broad securities into individual smaller segments. Here's a good example of how you might start with broad understanding of a process and then breaking it down into individual pieces. This is the document 800-171 Revision 2, which is Protecting Controlled Unclassified Information. And this is a table that maps the access control requirements to the security controls that are in place. For example, this page shows access control, where you would want to limit system access to unauthorized users, processes acting on behalf of authorized users and devices. This account management covers a number of different individual security controls. So when we start to break this down, we can look at user registration and deregistration. We need to understand how user access provisioning is handled, understand the management of privileged access rights, a review of the user access rights, and so on. By looking at these broad areas, we can now break down individual security tasks to see how well we're handling the processes and procedures for each of these individual steps. Once we've gathered all of this information for all of our processes, all of our devices, across all of our different locations, we need to create a final document that summarizes everything that we've discovered. We can start with a comparison that looks at the detailed baseline objectives and gives a perspective of where we are today versus where we would like to be with each one of these objectives. Perhaps the more difficult question to answer is how you get from where you are to where you'd like to be. This path to get from where we are to where we'd like to be commonly takes time, it takes money, there may be equipment that we need to purchase, and obviously there's change control so that you can implement these changes in your environment. Once we have all of this information compiled and the plan of how we can get from where we are to where we'd like to be, we can create a final gap analysis report. This report not only includes the information about where we are today, but it also provides that pathway so that we can understand what it's really going to take to move forward into the future. All of the recommendations you have about meeting this baseline will be documented in this gap analysis report. Here's an example of one of the tables that you might include in your gap analysis report. On the left side, I have a series of system requirements, and all of those system requirements were broken into smaller pieces in the detailed part of the report. But we might want to get a much broader understanding about all of our different remote sites and how they are compared to the ultimate baseline that we would like to reach. For example, our organization might have 7 different locations, and we performed a gap analysis across all of these system requirements for all 7 of those locations. The locations that are relatively close to meeting the baseline, we can mark with a green color. Anything that might be in the midpoint, we can mark as yellow, and locations that need a lot of work to be able to meet our standardized baselines, we'll mark with red. So if we wanted to have the biggest impact on improving our security, we may want to start with the locations and security requirements marked in red, and then move to the ones marked in yellow, and then finally the green. The report obviously will include extensive details about why these colors were used and provide a summary of how we can implement security controls to better meet the goals of these baselines.
Oh, Capital One, my team's transformer-based AI model.
Using contextual data helps personalize your experience in real time.
That's how it's that. That's technology of Capital One.
In many networks, you'll find that once you're through the firewall, the inside of the network is relatively open. People are able to move from system to system without any type of checks or balances. There are relatively few security controls in place, and this not only allows authorized individuals to move anywhere they like, but also allows unauthorized individuals and malicious software to do the same. But many security administrators are changing their network to be zero trust. This means that you have to authenticate or prove yourself each time you want to gain access to a particular resource. This applies to every device on the network, every process that's running, and every user on the network. As the name implies, with zero trust, nothing is trusted, and everything is subject to some type of security checks. This means you might be using multi-factor authentication during your login process. You may be encrypting data that's stored and encrypting data as it's traversing the network. There may be additional system permissions or additional firewalls that you're installing, and there are a number of different security policies and different controls that may need to be added to create this zero trust environment. One of the ways that we can start examining and implementing zero trust on our networks is taking our security devices and breaking them into smaller individual components. We commonly refer to this as separate functional planes of operation. So whether it is a physical device, a virtual device, or a security process that's running in the cloud, we can apply these different control planes to every single one of these security controls. Broadly speaking, we can look at these as having 2 different planes of operation. One of them is the data plane. The data plane is the part of the device that is performing the actual security process. So this might be a switch, router, or firewall that's processing frames, packets, and network data in real time. The data plane on these devices is processing any forwarding, network address translation, routing processes, or anything else that helps move data from one part of the network to another. But of course, all of this movement of data needs to have some type of management and control, and we perform that control in the control plane. This is where we manage all of the actions that are occurring in the data plane. This means we may be configuring policies or rules for a device to determine whether data may be used in the network, or maybe we're setting up policies or understanding how routing may be configured. So anytime you're referencing a routing table, you're looking at a firewall rule, or understanding how network address translation should be handled, you are configuring in the control plane. One way to get a better understanding of the data plane versus the control plane is to see how this might be implemented on a physical device. Here we have a physical switch, and we want to be able to break out the different planes of operation. Down at the bottom of the switch are all of the different interfaces that are used to move data from one part of the network to another. And as we've already seen, all of the traffic that we're forwarding all happens on the data plane of the device. But of course, this device needs to have configurations. There needs to be network address settings or changes to how data might be trunked. And all of those changes would take place in the configuration of the device under the control plane. Of course, this separation of data plane and control plane is not just specific to physical devices. You might have a virtual switch or a virtual firewall that can also be separated into these 2 different planes. This same separation also applies to cloud-based security controls. For Zero Trust, we not only need to implement additional security controls, but we need to be a lot smarter on how we evaluate those security controls. For example, we can implement a technology called adaptive identity. This is where we are examining the identity of an individual and applying security controls based on not just what the user is telling us, but other information that we're gathering about this authentication process.
As it starts coming back from the break,
the source of the requested resources. Perhaps someone who is requesting data that's located in the United States is using an IP address that's in China. And if that occurs, we may want to perform additional security to really confirm that this user is who they say they are. This might also include an examination of the relationship of this person to the organization. So are they an employee? Are they a contractor? Do they work full-time or part-time? And of course, all of this goes into the evaluation of this authentication process. We also want to look at things like physical location, the type of connection that's in place, IP addresses.
All right, welcome back everybody as we start getting into this.
About this user.
We're going to be getting into the second part of our lecture during the hour.
Create a stronger authentication if it's needed in this particular
There's one
case.
part of this I wanted to
Another way to control this
really
trust
it's not
is
back
to
in
limit
again, so
how
we're
many
going to talk about
places
SQL
it can use
injections.
to get into the network. So you may
And
want to limit entry
SQL
points
itself.
only being people that are inside of the building or connecting through
So
a
we'll
VPN.
just
There may
pivot,
be no other methods to gain access to this particular network.
see
And
where
once you have
everybody else is
all
at.
of this
Coming back
information
right
in
here.
place, we can now start creating what's called a policy-driven.
All right, for those who are
access
here, we're
that
just going to move
examines
forward. How
all
about
of
that?
these individual data points,
Okay,
puts them all
so
together, and then decides what type of
when we're
authentication
talking
process
about
should be used to
cloud
truly understand
security,
the person trying
there's a
to
couple of things that we have to
identify
keep in mind.
themselves
We've
as
thrown
that
around
person.
a couple of different
Another way
acronyms.
to
We're going to start getting
qualify
into
the identity of a person
OWASP.
is to
Have you ever
understand
heard of that
where
before?
they're connecting.
OWASP.
Oh,
And
what?
very broadly, we
Charles
define
says just here
it
smacking.
as security.
Open web
This
application
allows us to
security,
expand from something that is simply
right?
a
So that's going to apply for everything during the
where a
web.
user is logging into the
Uh,
server and instead looks at the
You're going to start
overall
getting
path
into,
of the
and I'm glad that Leah brought this up, so that's why we're going into,
where we're connecting from.
when you're looking at SQL injection,
So this may be
we know pretty much behind everything that you access on the web right now, there's a database behind it. Would that be fair to say?
Yeah, pretty much.
Especially when it's gathering information, right?
Yeah.
Especially if you're ordering something from Amazon. Charles Trump said, yeah.
This allows you to now
Especially when you're ordering from places like Amazon, doctors' portals, giving information, those are all databases that you have behind there. So, since I saw Leah there, she might be paying attention. She asked a good question. So what is the prepared statement for SQL? What I've shared with you is a website, and I'm pretty sure I shared this before. It's called w3schools.com. Okay? Now, before we get into it, if you go to the PHP page where it talks about SQL databases, PHP, when I was coming up and learning how to web page, yes, I was in school learning how to do web pages for a short while. And I was going to get my, I was going to be a webmaster,
Yeah.
right? I'll be putting pages together all the time. It was dope. Pretty much, you can do a dynamic page and everything is pretty much the same. You can change stuff.
Oh,
And
yeah.
I was doing it back then when it was Macromedia. Y'all ever heard of that? That's probably
Macromedia.
before your time. You have?
Yeah.
So Macromedia got bought out by Adobe, right? Then they started manufacturing web pages and doing templates. So then it went from knowing how to actually create websites to now they're template plug and play that you can do on sites like GoDaddy and One-and-One.
Yeah.
They pretty much stole the industry. They stole a whole degree program and they canceled it. So I was in school to do it. I was in for 2 years doing this stuff, like hand jobbing, like coding it.
Yeah.
And then I was in school at Capella University. And they said, hey, by the way, your webmaster degree program is no more.
What?
We can take all your credits and put you somewhere else, but as of next semester, nobody's doing it anymore. It's gone. I'm like, what? Yeah, it was horrible. Me and my sister was doing it. So I pivoted. I'm like, wait a minute. I'm a private investigator. I'm doing all this security stuff. Let me get my criminal justice degree. So I pretty much pivoted. So, when we're looking at this, PHP, when I was coming up, meant personal home page.
Denied or revoked. The policy administrator's job is to take
With
that
PHP,
information
you can connect
and provide that
to
information to the
and
policy
manipulate
enforcement point.
databases for
Access
PHP
tokens
pages.
or credentials that are created as a
SQL,
result of these policies.
database system used on the web, which brings us to, oh, what's there, Aaliyah, when we start getting into it.
This policy administrator. Now we can put all of
Database systems, of course, run on the server, so we've already shown to you before that you can have a server on your computer right now. Is that correct?
Yes.
Yes, we went in that. There's no
Yes.
hypervisor, different things like that, right?
Yeah.
Good for small, large organizations, very crude language to learn. Now, it talks about here connecting the database. When you start getting into it, SQL I believe this is on one of your objectives too. SQL I. It's not injection. It stands for improved. Okay. And you'll have to put into this database, there's a common thing when you start coding,
PHP
you have to
and
put
data
into your
objects.
objects. Even if you have an Active Directory or an LDAP, you're still talking about objects that you need to create, right?
Yeah.
You need a reference. You need to set what they call an integer, a variable. A lot of different things are the same. Placeholders. And in SQL, sometimes those placeholders can be question marks. Sometimes the placeholder, which you'll see on the exam, is called foo, equal, correct.
Yeah.
Foo, you'll see this on the exam coming up. Common placeholder.
Yeah.
This is a place in which you can replace this with any other variable that you want. And then this will allow you to start coding. And here's just some object-oriented. When you start getting into it, your objects could be server name, could be username, could be password. Remember what the I stands for?
Integer, you said?
Improved.
Improved though.
In anything, you're stating your language that you are using by this definition at the top left-hand corner. You can even see this in HTML web pages, right? Then you can create a connection to a database. $ connection equals new. Then you're gonna connect. You had a server name, username, and password. And this is pretty much how you're writing the language. And they're all different, right? They all have their different commands. The cool thing about learning how to write in a certain language, even though they're all different, certain things remain the same. And once you learn the structure, it becomes a little bit easier. I don't want to say it becomes easier.
Yeah.
It was a little bit easier. Now, when you get into creating a database, again, you're using your objects here. But the cool thing that you see here, so we don't go too far into the weeds, is right down here. Oh, where's it go?
Here's an example of one of the doors to an access
One second.
vestibule. This one
We're looking
has
for
a
statements.
card reader or biometric reader on the outside that could allow you access to the room.
Where's my
At
statement
which point
page?
You would check in with security, provide
Bingo.
authentication, and they may give you a pass or a card to allow you access to the rest of the facility.
Okay.
This is very common for very large.
If you're looking for prepared statements, basically what you're saying, Aaliyah, is, let's say, all of us in here, let's relate this to HTML. Let's say all of us are going to visit this webpage today, right now. Fair to say, 9 of us are going to visit, right? But what happens is, when all of us visits, especially if you're using individual computers, it'll cache this page for everyone. Fair to say? We learned that, right? Caches it. Okay. But the one thing that we cannot control is that the way all these pages are stored, when they're deleted, how fresh is the cache, because we can have 9 different ways in which to store this information and refresh it. Would that be fair to say? because we can all do it differently. We'll set different security parameters. Okay? If we're talking about coding in SQL, just to keep it simple, and you want to prepare, and Leah put it up here, prepare a statement. Now we're basically saying we have many pieces of code on a page, but let's say all these pages, let's relate it to code, all these different statements or objects are constantly being reused within the program. Mr. T's like, yeah. So with these, all you're saying is, with this, is that all of these variables typically are going to be used or pointed to be used in different coding transactions. Why don't we just set the statement here, and it's sort of like an encode library for everybody to go back and use it. All right, so now you're preparing a statement, and it can be referenced in different parts of the code to be executed in the database. Okay, so you're setting that PHP page. Now here's the difference though. Here's where it comes down to. You had another thing, SAST. The reason why you wanted to prevent SQL injection, and that's basically saying right here, hackers know how to use SQL injection against its own database. You're basically taking SQL code and using it against its own database. Okay? That's where you get these terms like 1 equals 1, that's SQL code. There's certain commands you can inject in a web portal. That's why when you see these search boxes and things like this, and you have to insert information, and they find out that it's being hosted like on an Apache server using SQL, they will try to break the database with its own code to basically let you walk into the database. So this whole page, if it was connected to a database and you put the right injection code, it'll just collapse and it'll just start showing you stuff. Right? So that's why you have to have what they call, oh my God, input analysis, or you have to test and try to break the database in production. Now, that's where it comes into here, where SAST comes into play. SAST, Static Application Security Testing. Static Application Security Testing. Where my DevOps folks at? Elaine, Kevin when he gets back, right? Brian, he looks like a developer. He's got that developer stare. But along the way, you are constantly testing and trying to break the code. You're also doing static testing to make sure that the basic, Elaine says, did some basic coding, started web design and development. Yeah, it's really actually pretty fun.
Yeah.
You're trying to break the code, implement security, and do DevOps all at the same time. So that's static code analysis. And then you're trying to make sure that there's no backdoors or any other pieces of code that's put in there and anybody else can access. So hopefully I answered your question, Malia. It was kind of like base model with an explanation, but that's what you get. That's what's going on with SQL. Now, if you want to learn how to code SQL or any other language, it's free right here at W3 Schools. Speaking of which, I'm glad we're here because Java and JavaScript, actually JavaScript, you'll see this in CYSA. You have to learn how to code or read a string. And on the CYSA exam, it will present to you a string with some variables, and you have to look at it and see what's wrong with it. You'll spend a lot of time trying to access pretty fun, huh? So if you want to get a head start, your knowledge and techniques of security to create deception, I'll drop this in the chat. To those
same.
Python, not so much Python.
One way to provide this deception.
JavaScript, well, Python, let me take that back.
Honeypot is a way to
Python's cool because it's kind of like a language that can transcend different platforms.
Yeah.
Easy to use. JavaScript, now you're looking at JavaScript JSON, JavaScript object notation, where now it starts to embed objects,
Yeah.
pictures, phone numbers, database links, embedding the object in the page, and then you'll have a security code that binds them together so nobody could jack the code.
Yeah.
Yeah, Java's more versatile. Yeah. So if you're looking at the two, that's what it comes down to. So even in JavaScript, you need to know variables, constants, types, conditions, loops, strings. All of this is going to be on the exam. As you go through here, doing the tutorial, it tells you, would you like to try this yourself? You can even walk through and try to code yourself. W3 Schools has been around since the 80s. I've been using this one early 90s.
Wow.
Good stuff. New language to learn now. Yep. There you go, Mr. T. And then you can actually run it wherever it wants you to type, and you're good to go. Now, if you sign up, I had signed up a while ago. You can get your own website when you sign up. They give you your own space, and it's more like a collaborative space
Yeah.
where you can create, and it's like your own small code repository. So you can share code, bring in code, build stuff, share it. It's like GitHub, right? Just on another level.
Yeah.
Charles said, I failed. I'm defeated. My brain just shut down.
Yeah.
So I know I'm giving you information before we get there, but you know how we do it. We need to lay the foundation. Hey, Aaliyah brought it up. She wanted to know, so that's why. Good stuff, though. I'm glad she did. Jesus says, dude, it's literally another language, yes. Yes, it is. All right. Fair? Questions answered? Somewhat? All right.
In your normal production network, no one should be accessed.
Let's shift our focus to cloud.
Does gain access to the file, opens or views the information. You may want to have alerts or alarms sent back to a management
What
station.
Aaliyah asked about with SAST, SQL, database, it does connect to the cloud. Because cloud instances are being ran in AWS.
Yeah.
Azure is connected from on-prem. You have backdoor links, right? You have to do code scrubbing. You have to make sure developers aren't leaving backdoors, notes in the code. So you have to make sure your cloud security is tight. Where all of you are entering right now in the IT, you're in the cloud generation. I'm in the RAID generation. It was RAID all for me it was all the RAID, right? RAID was the RAID.
Yeah.
Where you're at right now in IT, it's remote networking and cloud. So where you're at, you got to know this stuff, at least the basic architecture, because they're going to ask you. So we're here, it's going to go over the basics of cloud security. It's about 10 minutes, right? Then after that, we'll do a little bit of lesson. So here we go. Once upon a time, not long ago, people wore pajamas and left right slap, slick Rick, 1985.
Hi, I'm Nataraj Nagaratnam, and I'm from IBM Cloud. Traditionally, when you deploy an application, you have the entire data center, the servers that you run, you're responsible for all of it. In the cloud model, that's a shared responsibility between you and the cloud provider.
One single change could affect hundreds or even thousands.
In a shared responsibility model, you need to rethink security on what your responsibility is and what cloud provider's responsibility is. Let's take platform as a service as an example. When you look at PaaS, you're building applications, migrating data to the cloud, and building applications running on the cloud. So you're responsible for securing the applications, the workload, and the data, while the cloud provider is responsible for managing the security of the platform. so that it's compliant, it's secured from the perspective of network, the platform on down in terms of managing the containers, runtime, and the isolation, so that you have your own space within the platform. Whereas if you are adopting and migrating workloads to the cloud and you're using infrastructure as a service, then the cloud provider manages hypervisor on down if you are using virtual servers. Or if you are using bare metal, then you can completely control everything on up from the operating system, the virtual servers that you run, and the data you bring it on. So it's very important to understand the adoption model, whether you're consuming IaaS or PaaS, or if you're consuming SaaS, where the cloud provider manages all the applications and the security of it, and you worry about the data that you bring in and plan accordingly. So that's a very important thing, because it's part of understanding your responsibility in ultimately managing the risk and compliance of the workloads and the data that you bring to cloud. Now, let's talk about architecture. When you build applications and migrate applications and modernize your apps, let's start with data. With all the risk that you deal with, the kind of data matters. Is it confidential data? Is it public data or sensitive data that may deal with private information? Consider all those factors and make a secure design around what your data security architecture should be. Make sure you have data at rest encryption so that the data is always encrypted, whether you use a database as a service, object store as a service, or other ways to store data like block storage. Encryption is for amateurs. If you think about key management, is for professionals. So having more control of your keys provide you the ability in the context of shared responsibility model that you own your data, you have complete control of your data. So as you think about key management, make sure you have an approach to think about if you're bringing confidential data, you want to bring your own keys. Maybe sensitive data, you want to keep your own keys. So that how much control of the keys you have and the hardware security module in which the key processing, the encryption, decryption operations happen, more control you have, more responsibility that you can take on. So encryption at data at rest, data in motion, as it comes from services to data stores or applications, so that as you think about data coming all the way, your requests and API requests coming all the way, data in motion. And in the new world, we need to start thinking about when the application is actually processing the data, there is going to be data in its memory. So you can actually start to protect data using hardware-based technologies where you can protect in-memory data as well. So that when it is in use and in memory by the applications, you can protect it. So take a holistic approach to data protection at rest, in motion, in use, with full control of your keys. It can be bring your own keys, or even better, push the boundary with keep your own keys. The application that serves the data, it's not only about which application needs to have access. Make sure the data access is on only a need-by-need basis. Do not open up your data services to the whole world, be it network access or everybody to access the data. Make sure you exactly know which applications need to access or which users need to access the data to run your cloud applications. From an application viewpoint, make sure there are no vulnerabilities in your application. So scan your applications. So have an AppSec application security approach so that you can do dynamic scanning or static scanning of your application before you deploy it into the production. And in the cloud native environment, you are deploying container images. So you can scan your images. You can scan it for vulnerabilities before you deploy and set your policy so that you only have secured images in production anytime. And if there is any vulnerability in the new world, you don't need to patch these systems. You just spin up a new container and off you go. So that's the beauty of a cloud native approach, that you have security built in every step. So at a container level and the applications that serves the business logic, you can start to protect it. Then when you look at the users coming in, you want to manage access in terms of who the user is and what from where they are coming from. So identity, you need to make sure who the user is or which service it is based on the identity of those services or users, so that you can make access control to your application or data. And also from the perspective of network access, you want to make sure only authorized users can get in, and if there are intruders out there, you can make sure you can set it up so that they are prevented from accessing your application and your data in the cloud, be it through web application firewalling, network access control, or denial of service, distributed denial of service protection, and have intelligence built into these network protection as well. So both identity and network. In essence, you are protecting your data. You need to manage access to your apps and the workload and the data that you have deployed on the cloud. You need to have a continuous security monitoring so that you know at any point whether you're compliant to your policies. You can watch out for threats that you need to manage. Having an approach and set of tools to manage security and compliance posture is very important. So gaining insights about your posture, compliance, and threats. So from your deployment environment, you can garner information. It can be security events, audit logs, flow logs from network or system that can be fed in so that you can figure out what your posture and compliance and threats are. And not only it's important for you to gain insight, you need to have actionable intelligence so that you can start to remediate. You may figure out there's a vulnerability, a container image that you have deployed is vulnerable, so you can respin the container, so you can remediate and spin up a new container. There may be a particular access from a network that seems to be coming in from a suspicious network IP address, so you can block that. So ability to gain visibility and insights, and having that insights and turn it into actionable intelligence and remediate is very important. So let's talk about DevOps. DevOps is about development and operations. Traditionally, we think about, okay, there's an application team that is doing the design and architecture or building code, and then you throw it over the wall for the enterprise security team to secure it and manage it. That should be rethought. Fundamentally, it's not just about dev and ops, but security need to be a forethought, not an afterthought. So it should become SecDevOps approach to the way you build, manage, and run your applications. So you need to embed security into the entire life cycle, what we call shift left. Not only you manage security, but shift left through the entire process. You need to have a secure design. So as you plan, as you design and say, what kind of data am I going to put? What level of classification? What kind of applications am I building? Is it container-based? Is it a workload that I'm migrating? Take that into account, and what integrations you need to do so that you can plan it and architect it. Then as you build it, embed security as part of the process. So that you have security aware applications. For example, you may want to encrypt data. If it is sensitive data, you may want to encrypt the data from your applications before you store into a data store. So secure build, and you manage security. As part of SecDevOps, as you have secure design and architecture, you pass on that and build secure applications and deploy and manage security in continuous fashion. And then you have a closed loop so that whatever you find, you may need to remediate or re-architect your application or re-implement certain things as threats landscape evolve. Thanks for watching this video. If you
Dope. I love it. One thing I noticed about here, so you notice do you just see the difference on how they explain it here as opposed to when you're watching it in Skillsoft? What is the differences that you see when they try to do the videos in Skillsoft talked about cloud and different stuff? What do you see here between the way that they're doing it and you see it in your lesson?
Only after the new year are you now able to
And the lane is tight. Here we go.
control and begin the process of updating your systems.
Mr. T's got the bait.
Now that change management
So he's transmitting through
is a critical
thought.
part of your policies and procedures.
I'm getting it, Mr. T, I'm getting
Affects
it.
every single person
All right,
in
so
your
let's see.
organization. In almost every environment, this change control process is
It's practical app. You see it here, and this gives you a totally different way of looking at it.
Yeah.
Because when you see it this way, you can see how it is actually put into use and how it's linking everything together. Right? The security concepts, right? Defense in depth. Principle, did I say deft? Prevent. I'm tongue-tied. Defense in depth.
In our previous video, we
Right?
talked about the change management.
You also have principles of least privilege. They also introduced again zero trust, AAA, authentication, authorization, and accounting.
Yeah.
Right? And then they saw the crypto layer that they were talking about when people are trying to access through the server. Okay? Jesus, no yawning zone. You're gonna make me yawn. Oh my God, here it comes. You ever know some people yawn, you gotta yawn for no reason. Like you're just like, I don't know why that works. So that's why. So if we're looking at this, we left off at secure data destruction. So as we move into redundant strategies, you'll see some different things how even in cloud or on-prem, or even if it's a device, you want to make sure that it's being fail over, right? If the device does fail, it fails over into another working device. That is a backup or another scheme to the delivery of information. So let's talk about what they call continuity, all right? COOP, right? Continuity of operations. With this, you want to ensure that an organization can maintain or quickly resume its critical functions. Even if you have disruptions or doing disaster recovery or crisis, you need to regularly test your continuity of operations plans. Call it a COOP, right? Critical to ensure organizations can maintain these functions, and then you want to make sure that your backups are being done properly, so you can safeguard against data loss and you can restore anything you need to as quickly as possible. Now, I'm going to throw up some terms out here to you, because I know it's going to be on the Sec Plus exam, so let's just get it out of the way now, so we know how this works. In DNS, domain name service, what can you set up on the inside of the domain name service that ensures redundancy of data? What is that called? You're setting up your what?
Times where you have to make additional updates or expand the scope to be able to complete the primary goal of that particular change. For example, you may
And it relates to that first part up here, ensuring that an organization can maintain, quickly resume disruption to the disaster recovery or crisis. These are part of backups. So what are you setting up inside the DNS to ensure it's on or it can recover quickly? In the DNS.
There may be policies in place that allow you to make the decision.
The CNAME, the canonical name,
Yeah.
that is sort of the nickname, other names, other website addresses that you can point to.
So that everyone understands the procedures that should occur.
That's part of the A record.
Okay.
The change control.
DNS.
When most people hear the term change control, they automatically think about.
And think about different, I know, Michael, I'm trying to point you out in the right direction. Think about this. In DNS, you have your primary server. So what do you have to set up if the primary goes down? It's not where you are, it's somewhere. Failover. Hot side is more physical. Am I going to win this one? Please tell me. Mike says, go ahead. I'm going with Mike. So before y'all answer, let me just solidify this in the chat.
it's switched to a secondary
1
system.
point for, that's an exclamation mark. Meant to say 1 point. 1 point for me. Thanks, Mike. Appreciate it. Y'all got me this morning. 3-0. I got one. 3-1. You need to set up your DNS zones.
Oh, DNS.
This also allows you to
Your
monitor
recovery
changes.
zone.
Oh,
Yes, Charles.
You
Yep.
can switch back to the secondary
So,
which is
if you're having a server and you're seeing this in a cloud environment, this is going to be on the exam. So
by simply pointing all of your
I was trying to tell you. I said I was trying to tell you that. It's those DNS zones. Now, listen, you can have your primary zone on the West Coast.
potential outages that may occur.
You can set up your alternate or backup zone for a server that's on the East Coast or Australia, for all that matters, just somewhere else. So it'll point over there if your primary zone shuts down. And your other backup zone is for like out-of-band management. Or you have other third parties that need to log in through the DNS to manage it on your behalf. Maybe there's something they need to do or administrative function. So you can create a zone for them to get into. Does that make sense? Woo! I'm about to get another one. Watch this. Mark was like this. He's like, okay, I see what's going on here. What is it? What are the three? Charles halfway answered this. What are the three different sites we can have?
Oh.
Yep, hot, cold,
Yeah.
warm. Bingo. Charles got it. Way to go.
Is that
Yep. Which takes the longest to spool up?
cold site?
Cold.
Yeah.
Yep. Which one has personnel walking through it every once in a while? Every once in a while.
Warm. Yeah.
It's not fully there.
Yeah, but
All they do is come in
and
turn
check
the
on
lights on and
things.
off,
Yeah.
check the heat,
Yeah.
maybe load it back up,
Yeah.
and they walk out.
Yeah.
It's not on all the time. Of course, hot is now that we lead to that.
It's the DNS.
See what I did there? Dad joke.
Zone.
So, the hot site you'll have for disaster recovery is the DNS zone for continuity within the same network. It is continuity for the hosted website. Yes, the network.
Okay.
You're correct. It's all connected. Yes.
Okay.
If you're an enterprise environment.
Okay.
So, when you have a hot site, you want to make sure is that data mirroring all the time? Is it just selected times that you want it to copy everything? So you got to figure out what's best for your organization. In the cloud, it's so easy to move stuff. Would you agree? It's so easy to copy and move stuff. But what do you need to account for that could blow your budget? What do you got to look out for in the cloud? Because it's easy to move. You got a lot of stuff to move back and forth. But what can you run up?
Complicated because of dependencies. With dependencies, you have to first make a change to one application or service before you're able
Data's
to
big.
install or
It's
update
easy to
another
move.
application or service. Or it may be that the service
Corporations has to account for this because it ain't free.
secondary service.
The cost of the storage. There you go. Multi-tenancy and price. You got it.
We thought we were updating and
So
changing
you have to
the
keep track of that.
and now we have to update
Servers being spooled up, running at 1 cent per minute, or 1 cent an hour, or whatever it is, right? So you got to make sure you keep account of all this cost because elasticity. See, we're bringing it back. We're bringing it back.
Yeah.
Do you need to scale very quickly? And elasticity, right? Depending on what you need. So, right there, capacity planning is critical process in which organizations assess their current and future resources. You got to keep that in mind. With capacity planning, people risk, cross-training, remote work plans, alternate reporting structures. Always keep in mind how many folks you got outside the castle trying to remote into it.
process.
And then how many folks you actually have walking into the castle to work every day.
Yeah.
So you have two populace of people, right? Then on top of that, you have third-party vendors that log in to do stuff. That's another group you have to keep track of. Changes in the workforce capacity, which we just said. Rapid hiring, and then you have to have layoffs. I remember when IT departments were huge. They were huge. You'd walk in, half the people twiddling their thumbs because there's not enough work to do, but they get paid, right?
Yeah.
But it's not like that anymore. Since COVID, they figured out how to do a lot with less people. That's where you see IT where it's at right now. It's kind of like a fallback from COVID, trimming budgets and stuff. Because what's constant is that the machines, you'll never decrease the amount of machines you use, but you can reduce the personnel to have more efficiency. I strongly believe that the hiring market for IT is gonna go back up. It's just gonna be a new model.
Yep.
Right? And where do you fit it at? Yep. Now more automated. So with high availability, and we'll cover this slide and then we'll go to break. With high availability, how many? So what's the nines? What's the 5 nines and the 6 nines of the high availability? How many seconds per year did we say the 6 nines were?
Oh.
That a system could be down. That means it's 99.9999. What's the 6 nines of high availability? This is actually a test question.
With digital certificates. Although that seems relatively straightforward,
Not specifically, but in that realm.
the smallest of companies, this can involve a great deal of planning and a lot of decisions that have to be made about the encryption and methods that you use within your company. You might also hear the term PKI.
Jesus knows. He's researching right now. He's like, look, I got it.
People or devices. This is usually in conjunction with a certificate authority or CA. And it's generally
31.5 seconds per year. Are you kidding me? That's crazy.
Yeah.
But you know, they spend millions of dollars to have
public key encryption. Let's
right?
start with Symmetric.
Those are the websites that,
As
yep,
this name implies,
can't have that downtime like Google.
anytime you're performing a decryption of some
So
information,
imagine this.
the same key that was
When
used
organizations pay for let one less 9 be on there, spending less money, you'll see it on how you interact with a website. You can notice. All right. So with that high availability, to keep that up, ensuring the cloud, on-prem, scalability, elasticity, fault tolerance, and redundancy. When we talk fault tolerance, we know this. This is superficial information. What's fault tolerance? It's redundant. But what is it? Like,
Yeah.
we say it all the time, but what is it? What is fault tolerance? Somebody give me the explanation of fault tolerance. I don't want y'all to be up here. I want y'all to be down here with knowledge. This is going to help you in a job interview. They're going to be like, oh, well, everybody says fault tolerant. Okay, next. Who's this person? Hey, tell me fault tolerance. Next. Everybody in the interviews is saying, we need fault tolerance. Do you know what it is?
10 individuals or devices, it now becomes very difficult to not only share the keys.
Oh, he asking? Okay. The ability to.
How would you implement fault tolerance in an organization? There's so many different ways. How would you do it? Tell me.
Dive deeper into the world of cryptography.
I'm pushing y'all to the limit here. Can you tell?
Still use symmetric encryption quite a bit. And the reason
Backups can help you.
it's
How?
very fast. It has very little overhead as compared to something like
Trust me in helping you, Charles. I don't want you to drop a word. Give me a sentence like, how would you use it? Like,
asymmetric encryption.
bingo, here we go. Ability to continue operation even if one fails.
Symmetric encryption is encrypting and
Love that energy.
the same key
Redundancy, implementing RAID.
is
Correct,
encrypting and
right?
decrypting with two different keys.
When you start getting into your job interviews here pretty soon,
And the other key for decrypting.
that's what they're going to be asking. They don't want just the one word answer. How are you going to do it?
Yeah.
Tell me about redundancy then.
That provides that mathematical relationship between those two keys.
If you say fault tolerant is the ability to continue operation, so what is redundancy? You can use backups to bring you back up after disaster recovery, or if you lost data. I've done it a lot. Cloud storage can be there. It's written in blocks. You see how I'm giving you an answer? Mine is more in tune, right?
Yep.
It's a little bit more in depth.
Yep.
There you go. Lane says by adding a fail-safe backup system, which gives you the redundancy.
Yeah.
Aaliyah adds on with that, you can add generators and ups to your architecture. See, now we're getting there. Now we're getting there. All right. Cool.
The private key that you have is the only key that can decrypt.
I did say after this we were going to go to break, so let me be quiet.
For example, there may be a number of different
by doing snapshot on the system, implement policies. That's where mine should be at. Those type of answers, a sentence. Okay? Before we go to break, I'm gonna ask you one. I'm gonna see where your mind is. We'll see where your mind. Y'all don't mind if I'm pushing y'all to the limit.
No,
that's
fine.
It's your brain kind of formulating.
Yeah, it's good.
All right, so if we were in a job interview and we're talking about Network Plus, and I say, in our organization, we're having a hard time getting control of our employees not being productive. When we walk by a desk, we see more people on sites that are non-productive sites. What would you, how can you help me do that? I need somebody that can come in today that can help me with that. What can you say? Not just words. Give me a sentence.
And it usually involves a lot of randomization, a combination of.
Charles says, let's go. I would implement content filter. Okay. Aaliyah says, I would enable content filtering with the firewall. Then I'm like, oh, okay, dope. Let's see, we can use content filters to block certain sites so that you gain access to more productivity or URL filters. All right, give me some more. Come on, Martin.
Yeah.
Elaine says, limit permissions through group policy.
Like, yeah.
You don't mind me pointing to you. Okay. Jesus says it depends on BYOD policy. Love it. Or if we are using hardware in that, you know what? You have to think about that. Because what if I block everything that's on the network? But Jesus is noticing what all people are going to do is just come and use their tablets and their phones. So now what are we going to do with wireless access points?
Yeah.
We're pivoting. So now you solve one problem. Now everybody's using wireless access points. Now what are we going to do? What are we going to do now? Use role-based so that their productivity can be monitored. Okay.
Yeah.
You just lock down the network physically. What about the wireless access point with people with BYOD? Can you implement a geofence to restrict within certain areas? Yes, you can.
Yeah.
Bingo, love it.
Yeah.
Play chess while employees playing checkers. That's what we're doing. Yeah. So you gotta be able to see where. I love it. Give yourselves a round of applause. Let's do some cheers. Here we go. Everybody do a reaction. 1, 2, and go. Yes, love it, folks. Love it. Your minds are working. This is gonna help you on the exam. At that point, we're back to the plain text. This is the type of question Security Plus is going to ask you as a managerial function. Not really, you got one foot in as a worker bee on the network, but you have to think this way for Security Plus.
Yeah.
Like what we just did. All right, good job. Let's go to break. See you in 10 minutes. But when you're working in an environment with hundreds or thousands of users, and each of these users has their own public and private key pair, you may need some way to manage that very large amount of data. This may be a third party where you hand over private keys and they maintain those private keys until you happen to need them. Or perhaps you're performing your own key escrow. Once everybody creates their keys, you can store
store the keys locally, and if that user happens to be in a company or a different department, you'll still have the private keys so that you can decrypt everything they've been working on. This is something commonly seen when you need to provide some way to decrypt data, even if you're not the person that originally encrypted that information. For example, as we mentioned earlier, a user may leave the organization, but we still need access to all of their encrypted data. Or it may be a government agency that is working with a partner, and both of those organizations need to decrypt data that may have been encrypted as part of this project. Handing your private key off to someone else